All right, welcome. Today, we're doing a little more than just solving a coding problem. We're actually going to go on a journey of refinement. It's all about taking a perfectly good idea and figuring out how to transform it into something truly great. Let's get into it.
Okay, first things first, let's make sure we're all on the same page here. An anagram, it's just when you take the letters of one word and rearrange them to form another. The classic example you always hear is listen becoming silent. You've got the same letters, the same number of each letter, just in a totally different order. Simple enough, right?
Okay, but that's how we see it as humans. The real trick, the fun part, is translating that intuition into code. How do you actually program a computer to look at two different strings and say, yep, these two are made of the exact same character DNA? That is the puzzle we are going to solve today.
So let's dive right in with what I'd call a really good first attempt. This is the kind of solution you might come up with when you first tackle a problem like this. It's super clear, it makes a lot of sense, and you know what? Most importantly, it works. Here's what that first attempt looks like. You can see the function creates two separate dictionaries, one called COUNT_s and one called COUNT_t. And their job is to just store the character counts for each string. We loop through the first string, then the second, and for each character we see, we check if it's already in our map, and then we just bump its count up by 1. Finally, at the very end, we just compare the two maps. If they're identical, hey, it's an anagram. It gets the job done, but let's see where we can make it better.
And you know, this approach has a lot going for it, for sure. It's correctly using hashing to count frequencies, which is definitely the right idea, and the logic is super easy to follow. But it's not perfect. The biggest thing is that it uses two separate hash maps. That means it's probably using twice the memory it really needs to. And that if-else logic for counting, it feels a little clunky. We can definitely do better.
All right, let's move to our next stop. We can actually make a huge improvement in readability without even changing the core logic. This is where we start to write what people call more Pythonic code. Leveraging the language's own features to be way more concise and expressive.
This slide really just says it all. That verbose if-else block we used before, it works, but it's messy. By using Python's built-in .get method, we can replace that entire chunk of code with one single beautiful line. It basically just says, hey, try to get the current count for this character. If it's not there, no big deal, just assume it's 0 and then add 1. It's such a small change, but it makes the code so much cleaner.
And here is the fully refactored function. Now, the overall logic is exactly the same. We still have our two maps, COUNT_s and COUNT_t, but just look at the counting logic inside those loops. That clunky if-else block is totally gone, and it's been replaced by that one clean line using .get. It's the same strategy, just way more stylish.
So far, we've made our code cleaner. Now let's make it smarter. This next step is the biggest leap we're going to take. We're going to fundamentally change our approach to solve the problem using less memory and, honestly, with an even more elegant logic.
The key insight here, the real game changer, is this. We only need one map. Think of it like a balance sheet. First, we go through the first string, s, and we add every character to our map, building up our inventory. Then, we go through the second string, t, and for every character we find, we subtract one from our inventory. If the two strings really are anagrams, what should happen? Our balance sheet should be perfectly zeroed out at the end.
And here is what that balance sheet logic looks like in code. We use just one map, count. That first loop builds it up, counting all the characters in string s. The second loop tears it back down, decrementing the counts for every character in string t. At the very end, we just loop through the map's values one last time to make sure everything is 0. This approach is so much more efficient. It literally cuts our memory usage in half.
So, we've solved the anagram problem in a really optimal way. That's great. But the reason this whole journey is so important is that this final technique, it isn't just a one-off trick. It's actually a powerful reusable pattern.
Let's just quickly recap our journey, right? Our first intermediate version taught us the absolute core concept of using hashing for frequency counting. The second, cleaner version showed us how to write more elegant Pythonic code. And that final, optimal version, that taught us a powerful pattern that saves resources by thinking about the problem as a balance.
And this pattern, this whole build and deconstruct a frequency map idea, is a cornerstone of so many other common coding problems. Seriously, when you're dealing with sliding windows or finding permutations in a bigger string or checking subarray frequencies, this exact technique is your go-to solution. Mastering it here gives you this incredible tool for your entire programming toolkit.
So here's the key takeaway I want to leave you with. The journey from a working solution to an elegant one, that's where the real learning happens. So take a look at your own projects. Where do you have code that's just, good enough? And how can you apply this kind of thinking to make it truly great?